The next speaker is Mete. Mete will be pre-recorded talk, but Mete will be on a Q&A session after that. So I think welcome, Mete.
Hi everyone, my name is Mete Atamel. I am a developer advocate at Google, and today I want to talk to you about choreography versus orchestration in serverless microservices. Now, first of all, what do I mean by choreography versus orchestration? Let's imagine a simple e-commerce transaction. In this transaction, you receive orders through a front end, then you authorize and charge the credit card of the user in a Cloud Run service. Then you prepare and ship the item from a cloud function. And finally, you notify the user from another Cloud Run service. In this model, you have four microservices, and they're calling each other directly through REST. What are the pros and cons of this simple REST-based approach? First of all, it's better than a single monolith. You don't want to put all these services together in a single application. So it's good that they are distributed. And it's also easy to implement. Services simply call the next service in the chain. On the other hand, you already have too much coupling between all the services. Each service has to know the next service, and it needs to make the call to the next service. Similarly, each service can be a single point of failure. What if a service in the middle fails? The whole chain breaks. And if there's an error, then each service needs to handle the error, and it needs to retry, and it needs to apply some kind of timeout policy. So all those have to happen within each service. And most importantly, who ensures that the whole transaction is successful? Each service can make sure that their part is done, but there's no one watching globally. Now, what you can do is you can take a different approach, and you can do an event-driven system, also known as choreography. In this model, the front end still receives the requests from the users, but instead of calling the next service in the chain, it just creates a message and puts to a message broker. Then whoever is interested in that order request will receive that message, in this case payment processor. It will process and emit another message. Now in this model, as you can see, services, they don't really know about each other. They're just receiving messages and emitting messages as they go along. Now in this event-driven model, things work, but imagine a more complex transaction where you have an inventory, you need to check the inventory, where you need to take decisions based on the stock, having the stock or not, where you might need to call a third-party API. How do you do that in an event-driven way? It is certainly possible, but it becomes much more complicated. So the pros and cons of choreography is that, first of all, in choreography, services are loosely coupled, which is a good thing. Services can be changed and scaled independently, which is very important. And you don't have a single point of failure. If a service doesn't work, the rest of the services, they can still receive messages and they can respond with messages as well. And events in general, they're useful if you want to extend the system. If you want to add a new service, for example, it's very easy to plug it in and just configure it to receive messages that it is interested in. On the other hand, now the system is becoming difficult to monitor because with all these events flying around, it's hard to track where something fails. If you need to apply some kind of error, retry, or timeout policy, then you need to apply those still individually. There's no central place for that. And the business flow, the way your business is defined, it's not that obvious anymore. You can't point somewhere in your system where you say, this is my business flow. Instead, it happens as a side product of your event system, but there's no single place for your business flow. And again, most importantly, who ensures that the whole transaction is actually successful? Each service can make sure that it can receive and respond with messages, but there is no one watching globally. That is still a problem. Now you can take yet another approach called orchestration. And in this approach, what you do is you still receive the request from a front end, but instead of calling the next service in the chain, or instead of emitting a message, you call an orchestrator. An orchestrator, it's an external service, and it calls the next services in the order that they are supposed to be called, right? So in this case, for example, the orchestrator will call the payment processor, and once that's successful, it will call the shipper, and once that's successful, it will call the notifier. And since orchestrator it's a central place, it can also act on errors. So if something fails in the middle, it can report that globally, and it can also apply global error policies and retry policies and things like that. Now, the pros and cons of orchestration is that the business flow can be captured centrally in the orchestrator, and once you capture it, you can actually source control it, and this is very useful. Each step can be monitored because orchestrator knows what to call and how to call it, and if something fails, it's very easy to see. All these errors, retries, and timeouts, they can be centralized, which means you can have global policies that can apply it in a single place from the orchestrator. And you are still using simple REST, so the orchestrator still makes REST calls, so you don't have to deal with the complexity that comes with events and event parsing. And services are still independent. They can still be deployed independently and they can scale independently. It's just orchestrator calling them instead of them calling each other. On the other hand, you have a new orchestrator service that you need to learn and you need to worry about. So you need to make sure that it's actually a resilient and redundant service. Orchestrator could be a single point of failure. So you need to make sure that your orchestrator is actually up to the task. And since you rely on task in orchestrator, you lose the flexibility of eventing. And this inherently means that you have more tight coupling between your services. If you need to introduce a new service, you can't just plug it into your system. You need to actually configure it within the orchestrator as well. So which one is better, choreography or orchestration? And the answer is, it really depends on what you're trying to do. There's no hard and fast rule on one is better than the other, but I think there are certain things that you can look for and see if certain use cases are better for choreography versus orchestration. So for example, if your services are not that closely related, you are probably better off with choreography. And if your services can exist in different contexts, so for example, if your notifier service can live in your checkout process, but it can live in other processes as well, then maybe it's easier to use choreography because you can then take it and plug it into different places easier. On the other hand, if you have a business logic that you can define in a flowchart, then that's when you should start thinking about orchestration. Also, if you have services that are close related, that usually go together in a certain order, then there's no point in trying to do that in an event-driven way. You might as well put them in an orchestration. And if you want to stay in REST, you don't want to deal with the complexity of eventing and different event formats and different event types, then maybe orchestration is a good solution. And it's not an either-or solution either. You can also have a hybrid approach where for closely related services, you can have orchestration in a bound context. And then this bounded context can be communicating with other bounded contexts using events. In this model, you are using orchestration, but each orchestration talks to the other orchestrations using choreography or events. All right, so this concludes the discussion of choreography versus orchestration. Now let's look at the landscape. What kind of tools and services we have in this area? Now for choreography, for event-driven systems, they've been around for a long time. So if you're running on Azure or AWS or Google Cloud, there's a lot of options like EventBridge and Event Grid, and on Google Cloud, EventArc. And if you want to stay in open source, there are projects like Kafka or other projects like Solus pops up. So there's a lot of choice here. Now, orchestration is relatively new, but there's, again, quite a bit of choice there. So on AWS, there's step functions. On Azure, there's logic apps. And on Google Cloud, there's workflows and Cloud Composer. I would say workflows is for more about orchestrating services, where Cloud Composer is more about orchestrating data. And there's also open source solutions like Apache Airflow that the Cloud Composer is based on. And last but not least, there's a serverless workflow specification. This is a spec from CNCF, And there's a working group that's trying to come up with a workflow specification that defines how the workflows are defined and how they're executed. So it's something to watch for as well. All right, now let's zoom into orchestration, because event-driven systems, I feel like most people know about it, but let's actually look at orchestration, and let's look at Google Cloud's workflows, which is an orchestration service, and see what it provides for us in terms of orchestration tools. Now, what is workflows? Workflows, it's a service from Google Cloud, and it tries to orchestrate and integrate different services. First, it can orchestrate the serverless compute solutions. So if you're running code on Cloud Functions, if you are running containers with Cloud Run, or if you are running applications on App Engine, you can put them in an orchestration in workflows. You can also include any Google APIs. So any Google Cloud APIs or any Google APIs such as Gmail or Maps, anything that you can call publicly with HTTP, you can include in your workflow. And on top of that, you can also include external APIs. So if you have an external API that you want to call like SendGrid or Twitter or something like that, you can include those API calls in your orchestration as well. So workflows tries to bring you a unified platform basically to orchestrate all these different types of services and APIs. Now, how do you define your workflow in workflows? You do it through YAML or JSON. So for example, in this case, let's say we have 3 services: payment processor, shipper, and notifier. These are Cloud Run services and Cloud Function services. And you want to call them in this order. So what you do is you create a YAML file. In this YAML file, you define 3 steps: process payments, ship items, and notify user. You can call them whatever you want. Then you define what you call in each step. So in process payment, you're calling the Cloud Run service. So that's the URL of the Cloud Run service, and you're making an HTTP post. And the input of the HTTP post is the payment details that you pass into your workflow. And then from that call, you get a result back, and you can capture that result in process results. And then you can pass that result to the next step, ship items, and so on and so forth. So you can see how we can build workflows using this YAML or JSON logic. So workflows provides the steps that I show you. So you can define any kind of steps in any order you like. It includes serverless pause. So let's imagine you're calling your steps, and at some point you want to stop and take a wait for an hour or more. You can add that as a step. And it also provides passing variables between steps. So everything that you want to pass from one step to another step is possible. And then once you receive results from a step, you can do light JSON parsing on those results. So you can receive the result from a step, and you can pick the JSON and pick the certain elements of the JSON if you like. On top of this, it includes errors and retries. So for example, if you have a step and you want to apply an error policy so that, if the payment fails, you want to retry 5 times, but you want to do this in an exponentially back-off kind of way, you can do that. You can even route your workflows to different services depending on the outcome of your service. So for example, if the shipper is successful, it returns with HTTP 400, for example, you can send the result to a notifier service. But if it fails with some other HTTP error, then you can send the result to a pager service and maybe let your support people know that the service failed. It also allows you to do conditionals. So for example, you want to read the inventory from a database and check some result to see if you're in stock or out of stock. So you can do that check within workflows. You don't have to write code. You just define it in your workflows. And then once you're out of stock, maybe you want to make a call to a supplier API, which is a third-party API, and order more stock. You can do that from workflows. So you can see how flexible workflows is with conditionals and third-party calls. And other useful features of workflows is sub-workflows. You can think of sub-workflows as methods that you can define, and then once they're defined, they can be used in multiple workflows. And we also try to make it really easy to connect to different Google Cloud services. So instead of you trying to create the HTTP request from the workflow, we give you a connector, which is an easier way to connect to different Google Cloud services. So how do you deploy, execute, and manage workflows? You can do it from command line. So this is how you deploy. Once it's deployed, you execute with this command. And finally, as it's executing, you can see the result again from command line if you like. Or if you prefer UI, you can take a look at your workflow in the UI in Google Cloud Console. So you can see here that we have the YAML on the left. And then you also get a visualization of your workflow on the right. And then from here, you can execute your workflow, and you can also see the results of workflow all from the UI. And you can do all of this, by the way, from code as well. So if you have some cloud function, for example, that can trigger a workflow, that is certainly possible. All right, so this is what you get with Google Cloud Workflows. Now, in the last part of the talk, I want to talk about a case study. So we wrote an app called Piccadilly, which is a picture sharing app that shows how to use Google Cloud technologies. And we initially wrote this in an event-driven way. And then recently we refactored it and we wrote it in an orchestrated way. So I want to talk about this application, and I want to show you some of the lessons that we learned as we made this transformation. So this Piccadilly photo sharing application, there's a link. It's part of a workshop actually. And if you go to this link, you can see the workshop and you can build this app yourself if you like. But basically in this app, you upload pictures. And once you upload the pictures, we use Vision API to extract the labels out of these pictures. And we also extract the dominant color of this picture. So which color is dominant in this picture. And then we display it to the user. So you can see here, for example, we have pictures, and under each picture, there's the label of the picture. So it tells us what the picture is about. And around the picture, there's a border as well that tells us the dominant color in the picture. Now, the way we designed this is that this was the initial design, event-driven design. And in this design, we have users uploading pictures to App Engine. So this is the front end. Then the picture goes to a Google Cloud Storage, which is a place to save any kind of files. And then once it's uploaded there, that triggers bunch of events. The first event goes to a cloud function called image analysis. This receives the image creation event, and it says, okay, let me analyze this picture. It uses a Vision API to do that. And then it saves the analysis results into Cloud Firestore. The second event goes to thumbnail service, which is a Cloud Run service that receives the image and it resizes the image to a smaller form. Then there's a third service that gets triggered on a schedule, and it goes and fetches the 4 latest images from the bucket and creates a collage out of those images, so a combination of those images. And finally, the last service, the image garbage collector service, receives image deletion events. And when it gets notified that the image is deleted, it will do a cleanup after the image. So you can see that this whole thing is event-driven. Image creation or deletion triggers all the services, but they don't really know about each other. They don't really care about each other. Everything just works in kind of like a choreography. Now, we rewrote this using workflows. And in this model, what we did is we changed our code and we kind of changed our services, and we let workflow drive the whole process. So what happens in this case is that the user still uploads the picture to the App Engine front end. This goes to the pictures bucket, and then this triggers the file creation and deletion events just like before. But then a cloud function picks that up and it just passes to a workflow. So this whole flow chart you see here, it's workflow doing the work. So workflow checks whether the event type is object deletion or object finalize. And if it's object finalize, it makes a call to the Vision API. It transforms the data by calling a cloud function and determines if the image is safe or not. Then it stores the metadata to Cloud Firestore. Again, this is workflows doing the work, not code. And finally, it makes a call to thumbnail service and the collage service by calling Cloud Run services. Now, if the image is deleted, then there's a separate branch. And in this case, we delete the image data from thumbnails and also from the database. Now, in this model, as you can see, there's workflows doing some of the work. But then in some cases, workflows can call other services like the thumbnail service and the collage service. But the whole process is very very, very straightforward. You can see the logic here. This whole logic is captured. You can see it. You can visualize it in the UI. And you can see when workflow does the work. You can see when workflow makes a call to an external service. So these are the different things about event-driven versus workflow. Now, once we made this transformation, we learned some lessons. So let me share those with you. First of all, when we went from event-driven to workflows, we went from multiple different event types. There we actually had 3 different event types that we had to deal with. So we went from parsing 3 different event types to simple HTTP calls. And that was quite refreshing because we didn't have to deal with all these different eventing formats. Secondly, we got rid of a bunch of code. As I mentioned, we didn't have to deal with events, so we didn't have to parse them. We didn't have to have a function to do image analysis. We could instead call the Vision API directly from workflows. We didn't have to have a garbage collection service because we can delete the images and we can delete the metadata of the images from workflows directly. So we had less code to deal with. We also had less setup because we didn't have eventing to set up. So we didn't have to set up PubSub. We didn't have to set up Cloud Scheduler. We didn't have to set up no event arc. All we had to worry about is to set up workflow. And then with that, basically the setup ended up being much less than before. And the error handling became really easy because in workflow, if something failed, you would see it right away. We didn't have to look at logs or we didn't have to figure it out. Workflow would tell us execution failed and we could see in exactly what step it failed. And then if we had to apply error handling, again, we didn't have to do it in our code. We could do it in workflows. So that was really useful as well. On the other hand, workflow was a new service to learn with its quirks and limited documentation. So it's something that we had to spend time in learning. Also, since we got rid of a bunch of code, we had to change those codes and convert them into YAML definitions in the workflow, right? So instead of doing Vision API call, for example, in Node.js, we were doing Vision API calls with HTTP from workflow, which was good because it was less work for us, but we had to define that in YAML. So it's a trade-off, basically. You have code versus YAML, and now sometimes converting code into YAML is not that easy. And also in workflow, there's a single YAML file. So trying to do too much in YAML, it might be basically too much for a single YAML file. Debugging, testing, and logging in workflow is quite early in early stages, and there's no IDE support. So the way we worked is that basically whenever we change something, we change the workflow and we deployed it. And then that's when we would see if there's a problem. I think debugging and testing will get better as we go along, but as of today, it's not like code, for example, where you can just write unit tests. You have to actually change the workflow, deploy it, and see what happens in order to be able to debug it and test it. We also lost a little bit of parallelism with workflows because everything in workflows as of today is sequential, although we are trying to add parallel workflow steps soon. But as of today, it's sequential, so that means we had to do one thing after another, right? Whereas in event-driven systems, you don't really need to wait for anything. You can just emit events whenever you want and respond to events whenever you want. So we lost a little bit of flexibility that comes with eventing, but at the same time, we got a lot of structure to how things run and how things are defined. And for me, the most important point is that we have a central place now where we can actually see our workflow and visualize it. And if something doesn't work, it's very obvious where it doesn't work. So for me, these are the main gains from workflows. All right, so this concludes my talk. If you want to learn more about workflows, it's cloud.google.com/workflows. If you want to do the workshop and build the application in an event-driven way and later convert it into an orchestrated way, I urge you to check out our Piccadilly serverless workshop, and the link is here. And if you want to check out the code, everything is open source. So that's the GitHub link for the code. And if you want to reach out to me, feel free to send me a message on Twitter. I'll be happy to answer your calls. Thanks a lot for listening to my talk. And yeah, thanks very much.
Thank you very much, Mete. It was inspiring and very useful session. And so great to see you in person in our virtual studio.
Yeah, thanks for having me. It's great to be here.
Great to see you, Matt.
Good to see you too.
Great talk.
And
thank you.
I have technical problem. I don't hear Matt, but I hear Sanchir. So Sanchir, if you hear Matt, just continue with asking him questions, and our technical team will hopefully fix my sound.
Of course, yeah, sure. So we have questions. The first one is from the Andre. Does the combining of choreography and orchestration efficient? I mean that you need to care about 2 additional systems. Is it better than microservices architecture or not?
Okay, I just want to make sure you can hear me, right?
Yeah, sure. I can hear you.
Oh, okay, good. Yeah, okay. So the question is it efficient to mix choreography or orchestration? I don't think it's about efficiency, to be honest. I mean, when you mix choreography and orchestration, you are trying to get the best of both worlds, right? Because in orchestration, what you're trying to do is that you have a number of services and you want to kind of call them in a certain order and bring some kind of order in how things are called. And this is useful in bounded contexts. Like, for example, if you have a checkout system and you have multiple services in that checkout system, that's a bounded context, and you want that context to be run in a certain way. So that's why orchestration makes in that sense. But let's imagine that at the end of the checkout process, you want to notify another service or another bounded context and let them know that the checkout is done so we can do other things. So at that point, you don't need the rigidness orchestration. What you need is basically just a message to let others know that, okay, I'm done with my thing. You can continue with your own process, right? So for that, event-driven or choreography is the way to go. So that's why I think combining them in that sense makes sense, because in places where you need rigid kind of structures, you use orchestration. But in places where you just want to notify others and you don't really care if they received it or not, or if you just want that flexibility, then you include eventing. So it's not about efficiency. It's about like what kind of flexibility you need and what kind of structure you need, basically.
Yeah, sure.
Thanks for answering. Right. I hear you well now. And then let me read the second question. Question from Alexander. Can we run orchestration approach on local environment without cloud? And maybe we could extend this question. Can we run both orchestration and the second approach locally?
So, well, it depends, I guess. So if we are talking about Google Cloud Workflows as the orchestrator, and if the question is, can we run that locally? The answer is no, because Workflows, it's a cloud service, so you have to run it in the cloud. Can you run orchestration locally, like in general? The answer is yes, because there's workflow specification from CNCF that I mentioned in my talk. And in that workflow specification, there's actually some local runners where you can specify a workflow and you can run the workflow locally, mainly for testing. I mean, you wouldn't do that for production kind of systems. So it's for testing. So yeah, the orchestration can be run locally for testing in certain platforms if you use the workflow specifications. But if you're talking about specific services like Google Cloud Workflows or AWS step functions, then you have to run in the cloud. And then taking the question to the other part, if you have event-driven systems, can you run them locally? For example, again, with Google Cloud, there's Google Cloud PubSub for event-driven systems, and Google Cloud PubSub is a cloud service. But there's also a Google Cloud PubSub emulator that you can use locally to kind of emulate the APIs of Google Cloud PubSub. So technically, you can run it locally. I mean, not the whole system, but again, for testing purposes. So yeah, I think the answer to both is basically for if you want to test things locally, you can probably do it in certain limited cases. But if you really want to run the full thing, it has to be in the cloud, or you have to set up your own Kafka cluster yourself. There is nothing that you can just run locally in a realistic way, I would say.
Yeah, thanks. And the question personally from me, I'm always learning geek, and just imagine that, of course, it's a totally great idea to know about both orchestration approach and choreography approach for all the developers and especially architects. But if you are a junior developer, where to start? So which approach would you recommend to start from?
Well, I guess what I would recommend is don't even think about choreography or orchestration because if you remember my talk, at the beginning of my talk, I was showing 4 microservices calling each other directly, right? In that approach, you're not doing event-driven because you're not sending messages, and then you're not doing orchestration because there's no central orchestrator. You just basically hard code your dependencies in a way. It calls the next service that it knows in the chain. So it's just service to service call. This approach is the easiest way to kind of combine multiple services together, but obviously it's limited, right? Because you need to have these dependencies hard coded, and if something breaks in the chain, there's no way to recover and things like that. But if you're a junior developer and you just want to get started, this is how you would start. But then as you run this in production and as things fail, you will probably start looking into, okay, what can I do to make this more flexible? So then you will start introducing event-driven to make it more flexible. But then once you do that, you will get the flexibility, but then you're going to be lost because you're going to have multiple services sending all these messages. Then all of a sudden you're lost. If something fails, you don't know where it failed. You're digging through like logs and trying to figure out how things failed. And then that's when you start thinking about, okay, maybe there's something central I can use, and then you'll start looking into orchestration. I think that will be your journey, but I think you should take the journey. So start with simple service to service calls, and then you'll get to orchestration in the end when you need it.
It's the best explanation of this learning journey. Really great. Sanchir, do you have more questions on your side?
Probably from my question, one question I have. So probably for my application that are probably already on a prod. So when I need to think about these models, choreography and orchestration, so where is a call to action that I need to think about it?
So I missed the beginning of your question. So your application is where? Can you give me the context?
Yeah. Sorry, probably some connection issues. Yeah, my backend, probably my application already on prod for now. Yeah, and we already have some users and have some additional stuff that already working. So when I need to think about choreography and orchestration, probably.
Yeah. I mean, you start thinking about choreography or event-driven systems when you need the flexibility. And what I mean by flexibility is that, if you have a single service, for example, then you don't have to think about any of this because it's a single service that doesn't need to communicate with anyone. So who cares about choreography or orchestration, right? And then if you have 2 services or 3 services, again, you probably don't need to think about this. 2 or 3 services, again, it's a very limited number of services. They probably call each other, and it's good enough. But then as soon as you start having multiple services, like let's say 5 to 10 services, and then you want to be able to introduce more services going forward in an easier way, then that's when you start thinking about event-driven systems, because you don't want to kind of change all your services to introduce a new service, right? And event-driven systems, they enable you to plug in new services in a much easier way. So when you feel like you need that flexibility of being able to add services or remove services without having to think about other services, then that's when you think about choreography. And then I would say you start thinking about orchestration when you start having too many services and too many events going around, because at that point, the reasoning of your service becomes really difficult, because you have all these sorts of, usually multiple event types flying around. You need to parse those different events. You need to send different events, and then if something fails, you need to trace it, right? So you need to be able to have like some kind of event IDs in your events, so that you can trace the events and then see where it failed. So you need to look at multiple places to figure out how something failed. So if you find yourself where you're kind of, yeah, I have all this flexibility, it's great, but then I'm kind of lost in this sea of logs and events, then at that point I would say, okay, look into orchestration, especially when if you think that your logic of your app is quite clear, you can describe it in a flow chart, then it's much easier to take that and orchestrate that using something like workflows. So if you can think that your business logic is a flow chart, then if you have multiple services and you're getting lost, then it's a good time to think, okay, maybe I can orchestrate this. Let me take a look at workflows or other things like AWS step functions or logic apps, and see if I can take a different approach and see if that works. So I don't know. I don't know if this answers. It's a little generic kind of answer, but that's what I usually think. Like simple services first, then get flexibility with event-driven systems next. But then if you feel like you need a little bit more structures because things are getting out of hand, then think about orchestration.
Yeah, great. Thanks for an answer. I think I'm gonna to include this stuff into my application. Yeah.
Oh, Mete disappeared. We didn't. Oh,
okay.
Oh,
yeah.
Back.
I dropped for a second.
Yeah. So to sum up, Sanchir and all our attendees, you will hear the ring. The bell is ringing when it's time to go back to watch or rewatch a session from Matt again about orchestration versus choreography. When you understand that your services, your architecture is not flexible enough, then you know what to do, right? Go to Cloud Builders Conference, search for this session, watch it, and you are safe. Thanks, mate. And it was great to meet you. Great to hear your presentation. And have a great day. Bye.
Cool. Thanks for having me. Have a good rest of the evening. Take care. See you.
Yeah. See you.